Okay, continuing on with the distance formula, we're just going to go through this and do this example, and then we should be good to go. In this case, the distance formula, so it's just talking about what it is. Distance formula, the formula for completing the distance between 2 points in a coordinate plane. If A is x1, y1, B is x2, y2 are the points in the coordinate plane, then the distance between A and B is what? So when we looked at this, and we already wrote this down up above, so I'm going to just write it again because I'm here and I have this, so I'll write it. So we have AB equals the square root of my x values, x2 minus x1 squared plus y2 minus y1 squared. Okay? That's my distance formula. So using that, let's solve the next one. What is the approximate length of RS, where R is 2, 3, and S is 4, negative 1. So we're going to use our formula and figure out what points we have in this problem. So instead of AB, I'm going to write RS, and then RS equals my square root, parenthesis, my x2, so we'll let this be x1, or we'll let this be x1, y1, and then this will be x2, y2 for those values. So S is 2, R is 1. So my x2 value, which is 4, minus my x1 value, x1 is over here by R, which is 2, parentheses, squared, plus y2, which is negative 1, minus my y1, which is 3, squared. Okay. So we have this equals the square root of 4 minus 2, which is 2 squared, plus negative 1, basically plus a negative 3, which is negative 4 squared. So this equals the square root. 2 squared is 4, so 2 times 2 is 4, plus negative 4 squared, that's like negative 4 times negative 4, which is 16. So this equals the square root of 20. And if we actually go and take this and put this into in our calculator, we'll get that the square root of 20 is actually 4.47. So since we're kind of rounding and doing some other things, we're going to say this is approximately. So it's like two little squiggle lines. I know that's not much different than my equal sign. So I'll try to see if I can. It looks about like that. It's equivalent to 4.47. Another way we could write this is we could take out squares from under the square root. I think you guys have done that before. 20, if we rewrote this, 20 would break into 5 times 4, and then we can take the square root of this 4 value. So we could say this is 2 square roots of 5 if we wanted to. We can only do that when we break out perfect squares. So some people like the answer like this, some people like the answer like this. For right now, I'm okay with this value, the second one, the first one, the 4.447. They're both technically right, it's just what they're asking. Do they want you to put in a decimal form or not? Something to note on this, when you do the completing the square and you find the distance, it doesn't matter which point you let to be x1 and y1. You just need to choose one point, let that be x1, y1, and then let the other point be x2, y2. Doesn't matter which one. So we're going to go do a guided practice one. So guided practice. So let's see if, I'm going to go ahead and write it down, then I'm going to stop the video. I want you to stop it. And then I want you to work through it, and then play the video back, and then it'll have all the steps and see if you get the right answer. So let's say we have a line segment AB, and that line segment has endpoints of A equaling 3 or negative 3, comma 2, and a B point of 1 comma negative 4. Okay, so again, my line segment AB has endpoints A negative 3 comma 2 and B 1 comma negative 4. So go ahead and stop the video, work this out, and then play it again. Okay, hopefully you paused it and now you're joining me back once you're done. What I did was I labeled my different points. So this is my Y up here, Y, or my ones and my twos. And then I just plugged it in, making sure I kept my parentheses around my negative numbers. That way I know I have two negatives, which make it positive. And then negative 4 minus, or a negative 4 plus a negative 2, which is a negative 6. When that squares, we get a positive 36. And we get a 5, which is squared is 25. Gives me a square root of 61, which then is equivalent to 7.8 approximately. So we have the little equivalent marks, which means equal to in this case.